Hi, my name is Sahil.
And my name is Amanda, and today we will be presenting on a topic that has majorly affected the Earth. Our topic is Mercury's impact on the environment. As a very brief overview, we will be assessing the impacts of Mercury, its risks to the ecosystems, and to humans. We will be covering 3 key concepts that is connected to mercury contamination. We will be covering how it is emitted, for example, the process, its toxicity to ecosystems, and how we as a population can decrease mercury emissions so we can prevent mercury poisoning. So just what is mercury? It is a naturally occurring element that is found in Earth's crust. Mercury is the only metal that is liquid at room temperature. It is mainly extracted through an ore called cinnabar. This picture shows cinnabar displaying a nice red color. Mercury can come in 3 different forms. The first is elemental mercury. The second is inorganic mercury, which has a 2+ charge. Sometimes it can have a 1+ charge, however, this is rare. And the third form is organic mercury, also commonly known as methylmercury. There are other organic forms, however, this form is the most commonly present. This form is also the most toxic. So exactly how does mercury get released into the environment? In its elemental form, it can either be released through volcanic eruptions, which is the most common natural source. It can also be anthropogenically released through the combustion or burning of coal, or through small-scale gold mining. To better understand the toxicity of mercury, it's important to understand its cycle. First, elemental mercury is released into the atmosphere by various sources. In this diagram, the P represents particulate matter, which is what mercury complexes with to reach the atmosphere. Secondly, sunlight converts elemental mercury into inorganic or ionized mercury, which will fall down to the earth through rain. Some of the inorganic mercury will be converted back into its elemental state. Some will fall to the seafloor attached to organic particles, and the remaining will enter the food chain. Inorganic mercury on the seafloor will combine with sulfide to produce mercury sulfide, or HGS, in the sediment. Then, microorganisms will transform the inorganic mercury to organic mercury in low-oxygen sediments. Lastly, organic mercury will be taken up by low trophic level organisms and will bioaccumulate and biomagnify to larger trophic level animals. So what is the worldwide distribution of anthropogenic mercury? First, we have to take into account how much is actually emitted. The approximate estimate of emitted anthropogenic mercury is 2,220 metric tons per year. The regions that account for most of these mercury emissions between 2010 and 2015 are East-Southeast Asia, Sub-Sahara Africa, and South America, as seen on this graphic where orange and red show high emission rates. Although there are actions taking place to reduce emissions and to slow decreases that have been observed, rises are mainly seen in sectors that undergo extensive industrial activities. Now that we have examined how mercury enters the environment, it is crucial to understand the reasons behind its toxicity and the detrimental effects it has on various environments across the globe. The topics of discussion in regards to toxicity of mercury include toxicity to aquatic environments and toxicity to terrestrial environments. As a brief graphic, these diagrams illustrate and display the movement of mercury across both marine and terrestrial ecosystems. We will first examine mercury toxicity in aquatic environments. Due to various mercury emission sources, mercury has vastly become a serious threat to our waters. Mercury is extremely poisonous due to its very potent neurotoxic nature in numerous aquatic organisms. It makes its way predominantly into every aquatic ecosystem, contaminating the wildlife there, especially the fish we eat, so this is a major concern for us. It's important to know how mercury finds its way into water. So how exactly does it do this? It can enter water through atmospheric deposition, runoff from land, or industrial discharges. How does mercury biomagnify in larger predators? Well, first, once mercury finds its way into water, it goes through processes leading to its toxicity. Inorganic mercury is converted to its toxic methylmercury form by microorganisms, and small organisms will consume mercury-contaminated food. The mercury inside their body will bioaccumulate. As larger predators consume their now infected prey, the concentrations of mercury becomes more biomagnified in their body to harmful concentrations. This process will continue, making its way through higher trophic levels. So what happens when harmful concentrations of mercury is biomagnified in large sea animals? Adverse physiological effects will take place in aquatic organisms. For marine mammals, reproductive failure occurs. Another adverse effect are behavioral changes, keeping in mind that when it's in its toxic form, mercury is a neurotoxin. Lastly, death can occur in some cases. In large predatory fish, developmental abnormalities can occur, reduced reproductive success, and impaired growth. Along with physiological effects, it's also important to note what mercury contamination can tell us about water conditions. Sediment mercury serves as a key indicator of both the recreational safety and ecological well-being of Earth's waterways. By assessing the levels and spread of sediment mercury alongside with methyl mercury concentrations and the potential for bioaccumulation, we can gain insights into possible risks to human health and aquatic wildlife. So that, in a nutshell, is how mercury toxicity occurs in aquatic environments. Now I'll pass it off to my partner Sahil.
Thanks, Amanda, for that detailed explanation on mercury emission and toxicity to marine environments specifically. Now, let's take it away and discuss mercury toxicity, but this time for terrestrial environments. Okay, let's kick it off with the toxic effects of mercury on terrestrial environments. There's impact on vegetation, emission and re-emission of the mercury with the atmosphere, formation of methyl mercury, the transportation and mobility to longer distances, the fact that mercury does not degrade, and the increased accumulation of mercury in the soil, all of which either are toxic or make mercury even more toxic. Now, let's look at the mercury pathway in soil itself. So, increased mercury has a very, very long half-life in soil because of its continuous cycles of emission and re-emission with the atmosphere, and the transportation, mobilization, the fact that it does not degrade, and its increased accumulation in the soil itself. This increased mercury in the soil with a very long half-life drives the formation of methyl mercury, which forms in soil when inorganic mercury is methylated in acidic environments low in oxygen with high mercury availability in the presence of reducing bacteria. The formation of this methyl mercury is very, very bad, as it poses a great threat due to its higher toxicity to living beings compared to inorganic mercury, which we'll discuss in a second, and it has the potential to bioaccumulate within the food chain. But Sahil, what does that even mean? I don't even understand. Why does this stuff even matter to me? Okay, let me tell you why. Increased levels of methyl mercury can bioaccumulate throughout the food chain, leading to increased concentrations as we move up. This process significantly increases the risk of mercury exposure for organisms at these higher trophic levels, resulting in serious health consequences for both wildlife and people. That could be you. Okay, Sahil, now I'm starting to get a little worried. But what does mercury even do to humans and other organisms? That's a great question. I would even say the perfect question you can ask in this scenario. Elevated concentration of organic mercury compounds can be lethal, fatal to humans and animals. Additionally, even small amounts can have severe effects on various organisms. Vergote in topic 14 heavy metals describes that mercury is both a neurotoxin and a teratogen, contributing to increased oxidative stress and damage within the body, particularly impacting the brain. Mercury has also been linked to harmful effects on the cardiovascular, immune, reproductive, and nervous system. Vergote explains that exposure to methyl mercury during pregnancy is very bad, as it can lead to serious birth defects. This is due to the fact that mercury passes through both the placenta and blood-brain barrier and can easily be absorbed by the digestive tract of the humans, causing sometimes severe impairments. Oh my God, Sahil, this is terrible. Now I'm really scared. But how do we stop all of this? Wow, you're on a roll today with all these amazing questions. The only answer that there is decrease emissions. How are we going to do it? We must focus on reducing mercury emissions by identifying those countries with the highest level of the mercury output, and we must implement effective new measures to decrease these worldwide emissions. Along with the global side, what else we can do is also modify our daily habits and choices to help lower mercury emissions. Both this global and local help can create an environment overall that can have decreased mercury emissions as well as decreased toxic effects of mercury. China stands as the world's largest emitter and consumer of mercury and has been the largest emitter of atmospheric mercury, accounting for approximately 30% of the global emissions. This is where we start. We need to implement ways to decrease emissions in China that will cause a global effect. So, how does the global leader in mercury emission decrease emission after all? 3 ways. It combats air pollution by the usage of the Minamata Convention and the Paris Agreement. What are those? The Minamata Convention was just a global treaty that was established in 2013, and it aims to protect human health and the environment from mercury's harmful effects. It works in concert with the Paris Agreement, which was adopted in 2015, and this agreement involves nearly 200 nations committing to reduce greenhouse gases. These two agreements/conventions together will decrease the mercury emissions in China by a lot. Both these agreements will work in concert to decrease emissions by reducing fossil fuel combustion and combating air pollution. It is said that there's approximately 1,150 metric tons of mercury being emitted by 2030, and that if both the agreements work in concert, this could decrease to 490 metric tons, which is a lot. Now, let's look at another global leader in mercury emissions internationally. This is the United States of America. The United States Environmental Protection Agencies, the EPA, has major contributions that has caused decrease in mercury emissions over time. Let's look at the timeline for the EPA's major contributions. In 1990, it canceled the registration of mercury as a fungicide in paints. 1995, it issued for large municipal waste combustors to reduce mercury emissions. And in 2000, it finalized for small municipal waste combustors to further limit these mercury emissions. 2003, the final standards for mercury emissions from chloroalkali production facilities were also established. And then in 2011, the MATS, Mercury and Air Toxic Standards, was established to reduce emissions from coal and oil-fired power plants, as well as pretreatment standards targeting dental amalgam waste to control mercury discharges from dental practices. Then we move on to 2013, where a rule was published that limits emissions from medical waste incinerators. Then 2015, the EPA finalized a rule revising regulations for steam electric plants to set limits on toxic metals and wastewater discharges. Alongside decreasing emission globally, we can also do it every day locally. We can decrease vehicle emissions, reduce industrial processes, stop burning fossil fuels, dispose mercury properly by taking it to the eco-station rather than throwing in the garbage, and choosing safer seafood and meat, as described in the marine and terrestrial environments, by choosing small fish or choosing mammals that are lower on the trophic level that do not have these bioaccumulated increased level of toxic mercury. This joint effort between local and global communities is essential for reducing mercury emissions and ensuring the health and well-being of organisms to the highest degree possible. Thank you. I hope this presentation increased your knowledge about mercury and what you can do moving forward to decrease emissions on a global scale as well as a local scale.
This is Amanda.
And this is Sahil
Signing off.